functions. Today, we're going to use our knowledge of transformations. Well, actually, that's more for tomorrow, but we're going to basically use our knowledge of the inner circle of transformations to graph circular functions. Okay, so we are working on circular functions this week, graphing them. We are going to start pretty simple, pretty basic, work our way up some more advanced. I just want to make sure everyone has this concept, so bear with me. All right, so to start, you guys have a sine and cosine graph. You guys already have those written down in your problem of the day notebook. Hopefully if you did write them down, you don't need to rewrite these, okay? But when we look at sine and cosine, and we look at them together and we compare them, we look at their similarities, as you recognize, they are the same size and they are the same shape, okay? And they're both considered periodic functions, okay? Being that they're periodic functions, they each have a period of 2 pi. And the period is the length of one cycle, okay? A cycle is where basically the graph, it has one starting point, it goes through one full time, and then the point where it starts to repeat itself, that right there, that is that one complete cycle, okay? So if you look at sine, you start here, go up, down, up. At that point, it starts to repeat itself, and that's where the cycle comes from, okay? And that is a full 2 pi radius. Same thing applies over here with cosine. All right, when your y starts to repeat itself, or your x starts to repeat, your y starts to repeat themselves, that is when you've gone a complete cycle. One full period. Max and min values of 1 and -1. They each have a max value of 1, a min value of -1. If you ever wondered why you can never take the sine inverse of like 1.5 or anything like that, that's why they're bounded between -1 and 1. You can't take the sine or cosine of a number that's bigger than 1 or bigger than -1. All right? That right there is called your amplitude, which is the difference between the horizontal axis to a max or a min. And it's 1 in this case. Now your amplitude won't always be 1 when you're dealing with these different trig functions, but your basic, I guess you consider them your parent functions, their amplitudes are 1, okay? And by horizontal axis, it won't always be your x-axis, okay? Sometimes the graph can move up, sometimes the graph can move down, okay? You can also look at amplitude as half the distance between your max and your min. That's another way you can look at amplitude. Or again, basically the difference between that midline to a max or that midline. Questions on this? Looking at some of the differences, not too many. Sine does pass through 0, 0. Cosine passes through 0, 1. And sine is an odd function, where cosine is an even function. Okay? If you guys forgot about even and odd things, odd basically means if you take your function and you plug in -x into your function and you get the exact opposite, it's an odd. Even, if you plug in a -x into your function and you get the exact same thing, so basically, this is saying right here is that if I plug in a -x into my original function, and after I simplify, I end up getting the original function that I started with, then it's even. Over here, I have it backwards, so if you want to look at this one, you can say, if I plug in -x again into my function, but I get the exact opposite, then it's odd. Okay? Prime example, if you look at the sine of What's the sign of pi? That's no power. What is the sign of pi over 2? It's 1. Okay? Now, I'm going to plug in a negative pi over 2. What's the sign of negative pi over 2? It's the exact opposite. Banging it off. Okay? I can do the same thing for cosine, picking the right one. Let's go, what's the cosine of pi? Cosine of pi is -1, sorry. And the cosine of negative pi is the exact same thing. It's even. Sorry, I was looking at the yellow. I'm like, no. I'm so sorry. Alright, so questions on that? Couple of differences. Now you can use these graphs to help you solve equations, alright? The one thing I need to make sure you guys know, remember to check your mode. Okay? The problem will tell you what mode you need to be in, okay? Now this is just an example. Okay, you don't have to write this down, you're gonna do plenty on your own, so just kind of follow along with me on this. Alright? Say you have sine x equals 1/2. Now yes, 1/2 is on our unit circle, so we can do that one very simply. Okay? But basically, you can take the graph of sine, this is just partial, part of the graph of sine, and you see the line of y equals 1/2. Alright? In between -2 pi and 2 pi, you're looking for your solutions. Alright? And your solutions for this type of equation are clearly where the two curves intersect each other. So between -2 pi and 2 pi, there are going to be 4 solutions that you would need to write down. Okay? And then whatever those solutions are, you want to make sure that they're in radian because of this little bit right here. The fact that they gave you your domain in radians, all your answers should be in radians. Now, since this is a value that's on your unit circle, and this would be a great time for some practice, what are my solutions? I should have 4. Where's sine 1/2? Give me one.
Sine is 1/2 at 30.
So in radian, that would be?
Pi over 6.
Very good. That's one solution. I need 3 more. Give me one. Matthew?
5 pi over 6.
5 pi over 6. Yes. Because remember, to find x, you basically are taking the inverse of sine and basically looking, okay, so where's the line? 1/2 cross sine.
Oh, I know what it is.
Now, the other ones are going to end up being negative, as you can see on the graph. Let me hear from somebody different. Yes?
-7 pi over 6.
-7 pi over 6. Yep. So that'll be -210 degrees. -11 pi over 6. Very good. That work backwards. Okay? Hope you guys haven't forgotten your unit circle, right?
No.
In the first place.
Okay. But sometimes it won't always be a value that's on your unit circle, and so then in those cases you are going to have to use your calculator, which is what the examples we're about to get. Okay, we're going to look at this one. It says solve the equation cosine of theta equals 0.4 theta.
That was the first problem on the homework. For section 2.
Is in between -360 and +360, and we're going to give our answer to the nearest 10. Because if you think about 0.4, that is 2/5, okay? Not really a value that's on your unit circle, so we have to go into our calculator. And we're going to basically have to graph this, okay? We'll graph the left side of the equal sign in y1, and then the right side of the equal sign into y2. All right, so go into our y equals cosine, and yes, even though it does say theta, we can just say x, just knowing that x, our horizontal axis, represents our angle, represents our theta, and then we'll type in 0.4 into y2. We got to make sure that we're on the right mode. Which mode am I in?
Degree.
So I'm going to go to mode. I'm going to make sure degree is highlighted, which in my case it is. And then on top of that, I don't want to just go ahead and graph it the way it is. I want to go ahead and fix my window. because I'm looking just between negative 360 degrees and positive 360 degrees. So I'm gonna change my x-min to negative 360 and my x-max to positive 360. So then that way I can get the entire sine curve in my picture. And I can also see where 0.4 intersects. Now 0.4, that is a pretty small number. And right now my y-min is between negative 10 and positive 10. I don't need that much. I really don't, okay? So I'm gonna make it just a little bit smaller. I'm gonna say it's between negative 2 and positive 2. Because remember, cosine, the graph of cosine, is bound between negative 1 and 1, okay? So that way when I go to graph it, that blue represents my cosine of x curve, so cosine theta, that left side, and then y equals 1/2, or not 1/2, 0.4, there it is. And so my solutions are the 4 points in which that red line intersects that blue line, or in y'all's cases, the black line intersects the black line, okay? So to do that, all you go is to second trace, go down to number 5, intersect, and you're gonna find the intersection of each one of these points, okay? Make sure you move your cursor over so that it's closest to the intersection point that you want to find. Click enter 3 times, and there it is. Rounding to the nearest tenth, that first value is going to be negative 293.6.
Do we have to use the graphing one, or do we use like inverse cosine? That's what I did. I just find it easier to do inverse cosine.
The first one I got negative 293.6, and then I have to find the other ones. Now, your question. Sorry, I was just trying to remember that number.
Do we have to, when we use inverse cosine, do you want to use the graph?
You want to use the graph, because with inverse cosine, it might only give you the ones that are in between negative pi over 2 and pi over 2.
I know, but then you have to use your 360, so you.
True, but I mean,
I don't know, it kind of takes up the same amount of time either way.
Because you have to hit intersect in 3 times and all this crap on here, I can do it like that. I like it.
so find my other 3. Find my other 3. You get negative 66.4? Okay.
Positive 66.4 and 293.6.
You guys get those? Okay.
There's a point where it's like.
Now remember, cosine functions are even. So that makes sense why they're like that. Okay? Now let's look at another one. You guys go ahead and do this one. Well, actually, we're actually gonna do this one as well together. So to go about figuring this out, this one's a little different. This right here is a linear function. So it's not going to be a horizontal line that's going to go in for y2. It's going to be one that's slanted. So I'm going to plug sine x into y1, and then 0.25x minus 0.3 into y2. I need to make sure that I'm in what mode? Gradient. And I want to make sure my window, my x-min, is negative 2 pi, and my x-max is a positive 2 pi, just to make sure I can see everything. Okay? Again, make sure you change your mode. Make sure you're in radian. Window, make sure it's 2 pi, negative 2 pi, positive 2 pi. because the restriction was for negative 2 pi to positive 2 pi. So because that was in radian, unlike the last one from negative 3 to positive 2, that's why we have to be in radian. How many solutions are we gonna have here?
Three.
You're gonna have 3. So 1, 2, 3. And it didn't tell you how to round, so what does that mean?
3 sig figs.
3 sig figs, very good. So if it doesn't tell you how to round, you automatically default to 3 significant figures. So find my intersection points. Well, tell me what the other two?
Negative 2.15.
And negative 0.416.
What'd you get?
Okay, I got, .386, negative .404.
Are you in radian or degree?
I think I'm in radian.
Check.
I'm in radian.
You're in radian.
Radians too, and I got
Did you type in the right equation?
With .25 minus .3.
I got the same as. Wait, 0.25x?
Yeah.
Minus 0.3?
Yes.
I got those.
Look at this.
You got these?
Yeah.
Okay, yeah.
You got
Matthew,
mine?
you just rolled.
No.
It is, so it, make sure it's always, it's the x values. Alright, here we go. Alright, so we're good? Good stuff.
But
Alright.
I'm solving for x.
Tangent's a little bit different. Okay, tangent's a little bit different. It is a periodic function because it does repeat itself after a certain interval. In this case, the period is pi. It does have vertical asymptotes, as you guys saw when we did our problem of the day. And it has no amplitude, unlike sine and cosine. Because unlike sine and cosine, it does continue out into infinity, positive and negative. And so there's no highest point it goes or no lowest point that it goes. There are no maxes and mins. So we're gonna do one more solving equation, and this is pretty much what your homework's gonna be like, okay?
We get to use a calculator.
You're gonna use your calculator on all of it.
Amazing.
That one I was expecting.
Aren't we about to get on?
Here it is. Check your interval. Find them.
Oh, our window. On the, Y.
You said that didn't matter.
The Y though, the Y is up to.
It's a lot better.
Yes.
You guys come up with 4 solutions? I mean, but there were 4?
Yeah. Yeah, we got
There should have been 4. In this case, you would have to open up your window a little bit bigger because there's no max and min. So you want to make sure you see exactly where the line intersects those curves in between negative pi and a positive 2 pi.
But when I put my x min as negative pi and then my x max is 2 pi, it gave me like kind of max.
But see, the thing is that curve that you have that's up here is going to intersect it still in between that. So that's why you want to make sure
So
you
what
open
would I
up
make
one.
my window?
You can go back to your standard default negative 10 to 10.
Yeah, the first time I got it, kind of goes hard. Usually like
You want to make sure you can afford that particular window. And you end up with 4 solutions here.